Okay, today we're drilling holes in a circuit board, some FR4. I have a drill map, and I'll go over what that means. I have my drill bits lined up, ready to go. There's a few, well over 100 holes to drill. I might just do the whole video with just drilling holes and see what I can talk about while I'm doing that. This video is sponsored by NextPCB. They are, and I wanted to talk about that. They're a considerable sponsor for KiCad, the PCB design software that I've been using nearly exclusively for the last nearly 20 years. 20 years, and yeah, the last 5 years it's really been taking off. In fact, DigiKey is also a sponsor for KiCad, and it was one of the reasons why I wanted to work with them, because it's for a good cause, and it is. I'm actually on the development team for KiCad. I'm not listed in the thing. I haven't contributed enough. It's my fault. I don't have time for it. But I am on every step that they do. They got a new version release coming up very soon. They're working on packaging right now. Okay, so I got work to do. So let's do that. Okay, here's the drill map file that I've printed out. You can see here that we have a number of different symbols here, and we have, just like a map, we have a key legend. Each individual symbol that represents a different drill hole size. It's both in both metric and in imperial, and along with the number of holes. You can see here there's a 3mm hole that's not plated, so that would be in the design file, the Gerber file that would go to the PCB fabrication house. That wouldn't apply to me because I don't do plated holes, because there's a number of chemicals that it's extremely difficult for me to get my hands on, and apparently they're precursors to make methamphetamine. So can't unless I get really creative and know somebody from the Midwest to help me out with that. I don't know. Next, you can see here 0.8mm. We have 105 holes to drill. If I were to start doing holes to make PCBs myself from home, if I were to start out, because I remember this being a main thing when I was first trying out, what drills do I get? What size drill bits do I get? You know, and nobody says, and nobody talks about that. What are the most common hole sizes? And along with, I was watching a video from the EV blog, and he was talking about the bill of material consolidation. Well, you can do the exact same thing here for drill hole sizes. You might have, like for instance right here, this 1.6 drill hole size. We can make all the 1.5s 1.6, but 1.6 is not that, in this case it's not that critical. So I'm actually going to downsize it to 1.5, and I will make a note on this page so that when I go back to the software I can revise that. So yeah, the 1.6 would be dropped down to 1.5. That would work. That would actually work in this application. Now keep in mind, if you go to a fabrication house, you might not want to use actual drill hole sizes. You might want to go a little bit above, because of the plating that reduces the hole size. You might want to look out for that. I had a customer's board, and it was a through hole board. The components were so tight that once they were essentially in the hole, mounted on the board and soldered, they would nearly be impossible. Even with a desoldering gun, even with one of these, it was extremely difficult to replace parts. So you don't want to do that. If you design your, yeah, you want to have wiggle room. You want to have wiggle room, but you don't want it too loose. And the customer was saying, well, there needs to be that hole size so that the parts don't fall off the board because of a lot of vibration. And my argument with that was, well, then you need to work on your soldering skill set, because if it's soldered properly, it's mechanically bonded, and you won't have to worry about parts vibrating off your board. If it's soldered properly, you won't have that problem. So apply more heat, apply more solder, and your vibration issues of your parts falling out of the board is solved. For instance, I wish I could show you an example right now, and you've seen it, called a cold solder joint, where the part literally can fall out and there's still the remnants, and you can still see the leftover of the solder that wasn't bonded to the component, to the lead, and the hole is still perfect, and you can still see the curvature of the solder. However, because the connection wasn't clean when it was first soldered, it literally just vibrated out. And he's mistaken, because it's not because of that. It's because it was a poor solder joint to begin with. And that's why the hole size, and now it's a real pain in the ass to replace the components on that board because of that. Anyway, I know I'm getting off the track, but we are dealing with drill hole sizes and stuff like that, so that's something to look out for too. So because this is being drilled at home here, actual drill hole sizes is perfectly fine, because they're not being plated. I don't have to worry about that. However, when I send this out, I'm going to increase these hole sizes slightly. So instead of, say, 0.8, I would put 0.9, and just go up 0.1. You would just go up 0.1 millimeter. You'd go up 100 nano. So, okay. So, and I would go through each one of those and do that. I'll also change the 1.6. I'll get rid of 1.5 and just keep them all at 1.6. So that would be 4 holes total. All right. So when I update it, but in this case, I'm going to downgrade it to 1.5. I'm trying not to confuse you, but there's that. If I were to get a new set of drill bits, this would be the set I would get. You have to get them all individual. I have a 0.3. There's a 0.8. There's a 1. There's a number 56, I believe. I don't remember what hole size that is. There's a 1.5. This is a 2.4. Come on, focus. It's a 2.4. This is a 3. This has this is really nice for cutting boards out for routing. And this is a 2 fluted end mill. This is really nice. This is a 0.2 millimeter V-groove bit. I don't know if you've ever seen one of these. They look like that. It's a 0.2 millimeter V-groove, and it doesn't have the ring on it. So I don't really care for that. This was a real cheap one. I couldn't. Yeah, and they bust often, so get a few of those. The 0.3 millimeter also is one that will break if you don't have a good concentricity on your micro drill. So you want to have a drill with really low runout. Okay. So, what am I doing here? So we're going to go with the 0.8. You typically start with the one with the most holes and go around and check and just correlate between the map and the actual board. So, and we'll do that. You can see how the there's 4 holes here for the heatsink, and there they are there, if you can see that. This is a double-sided board with surface mount, so it's a through hole and surface. It's a combination. So yeah, let's get going on the drilling, huh? I've been having issues with the my ring light that I had made. It's shorting out to the it's shorting out to the drill. So yeah, I don't know. So that's going to kick in and out. I'm drilling holes. This is going right in the bed, hopefully not into the bed, and going right through it. I'm trying not to hit anything here. I don't want to drill into the bed. That's still too low. Come on. I like that. Right there. Right there. Whoa! It lied to me. I want it right there. That'll work. That will work just fine. Yeah. Alright, yeah, so like I was saying, the light here will probably jump in and out. And we'll see what happens. If not, I'll have another one here. And let's see. Drill is on. There. I'm drilling at 20,000. So the I don't know how loud it'll be. I might have to actually move some of these. I should have done that already. I apologize for not being more prepared, but I'm just working. Okay. I gotta find my map now. And the camera's sitting on top of it. Perfect. Come here, you. That. So okay. Yeah, I'm just looking at where I need to drill, and I can recall from some of the footprints, because I laid out the board myself, so I know I have an idea of which components are which and what hole sizes I would need just from experience. For instance, this 28 pin dip chip here, I know that those are 0.8. I have some 6 pin headers here. I know that those are 1 millimeter for the programming header. I know that I have a dip switch here. Those would be a 0.8. And so on. Typically, dip pit, dual inline pins, chips are typically a 0.8. You can pretty much just go with that all the time, and you'd be fine. Typical components for through holes, say resistors, typically 0.8. You can't go wrong with it. You just can't go wrong with it. 0.8, it's typically the go-to, unless it's say a like a 1 in 4001 diode or something that is over here. That would be a 1 millimeter. And I actually might drop that down to a 41-48 because there's no reason. It's just um, it's for the breakdown voltage on the coil for a relay. So it's just, that's all it's doing. So a 41-48 in this case would be fine because the coil only pulls 20 milliamps and a 41-48 can handle 200 milliamp in the reverse. So it'll be fine. It'll cover it. It's actually, and the 4001 that I have on there now, which was an old component that was grandfathered into this design, it's beyond overkill. It's beyond overkill, and it's more expensive. The 41-48 is cheap, so I'm going to switch that out. Excuse me, in the bill of materials, and yeah, I'll make notes of all this stuff. But I'm literally just thinking out loud, and we're actually going to start drilling now. Okay. Yeah, here's another tip. See, I just made a mistake already. Nothing bad. See, I'm drilling from this side, and there's no traces from this side. This is just the top side of the board. And you can see here, the alignment's a little bit off. We're talking of fractions of millimeters here. It'll still work. However, it's going to be best that I drill from this side, because this side of the board, there's no connections. You understand? So, and by the time you're done drilling a number of these holes, you'll understand the offset, so that when you do have a through hole component that goes from one side to the other, you'll know the sweet spot to drill. All right. So once you get going and drilling through the holes and you go through the motions, you'll get a feel for where is where, and you'll discover your just from going through the motions of where the offset would be, just from hands-on feel, you know. So it's just something I wanted to mention. Not a bad idea to go on the back and double check your work. Just loosening up the loose bits. You can see they're not that bad. It's a little off. We're talking a fraction of a millimeter. I mean, we're really small. The tolerance is so close, it wouldn't matter. It doesn't really matter at all. You don't want to get much out of spec than that, though. Let's see. Got about 1,000 more to go. So I'll see you when I get to the next drill hole size. Well, I don't know what happened, but I lost the footage on the rest of the board. I don't know what happened. So the board's been drilled 100%, and there's the map. That'll be the end of part 2. Part 3 will be populating the board. So we'll see you then. All right, take care. Bye now.